KNN classifier. KNN classifier or the K nearest neighbors classifier. Let us see how KNN classifier classifies a new data point. When it gets a new data point, how does it perform classification? This classifier, it classifies a data point based on the majority class among its k nearest neighbors in the feature space. That is, it will first find its k nearest neighbors, then it will see among these k nearest neighbors which is the majority class. Whichever be the majority class, that is the class to which a new point will be assigned. Let us understand how this works. In order to get a better imagination of this, you can assume it like this. This is our feature space and let us say a lot of points are there. And I'm giving you a new point. Let us say this is the new point for which I need to identify the class. The first thing it will do is, it will develop a, you can understand it like this, that is, it will develop a sphere around this point which is centered on our data point. This sphere, it will keep growing till it reaches a size which includes k data points. That is, inside this sphere there should be k data points. Till that point the sphere would increase in size. As soon as it reaches the size in which there are k points inside, it will stop growing and it will see for each point inside the sphere what is the class. Let us say there are a total of 100 points inside the sphere, and let us say totally there are 3 classes, C1, C2 and C3. In this case, among these 100 points, let us say 40 belongs to C1 and let us say 30 belongs to C2 and 30 belongs to C3. In this case, what is the majority class? C1 with 40, right? So C1 becomes the majority class. Then you will say the new point, that is the new point that I have, that also belongs to C1. This is how KNN classifier does classification. What happens in the training and prediction phases? Let us understand this. In case of KNN classifier, in the training phase, it's very easy. Probably this is the easiest classifier or the simplest classifier in the training phase. Why is it so? Because in training phase, it doesn't have to do anything. It simply has to store all the training examples with their class labels. That is, each of the point, it should have the coordinates of that data point and then the class label. So simply it will have one point, its class label, one point, its class label, and so on. In the prediction phase, this is where the actual work comes. As soon as the prediction phase starts, the first thing is, given a new data point to classify, it need to calculate the distance to all its training examples. That is, let us say you have these points here. If you are considering, let's say, one point here, the first thing you have to do in prediction phases, to all the points in the feature space, you have to find the distance. This is the distance to this point. There is a point here. Then you have to find this distance. You have to find this distance and so on. So whatever be the number of points, to all those points, you have to find the distance from the new data point. This is the toughest part coming to a KNN classifier. That is, if you have a very large data set, for each of the prediction, you have to find the distance to all the other points. If you have a total of n points, for each single prediction, you will have to find distance to all these n points. That is, considering you have a new point coming in, you will have to find the distance to all these n points, and then only you can find the right prediction. What is the next step? Okay, I'll write the steps one by one. Then it will be clear. The first step is finding the distance. Okay, distance to all the endpoints. This is the first step. Second step, that is, let us say you already found the distance to all the n data points that you have. The next step is to select the k nearest neighbors of the data point. In order to do this, you have to compare all the distances that you calculated in the first step and identify which are the k nearest points to your new data point. Once you get the k nearest, so this k nearest neighbors, this is calculated based on the distance. So it can be Euclidean distance or whatever distance you want. Euclidean is a common metric that you use. And once you find the k nearest ones, the third step is to determine the majority class, right? Majority class. So once you find the k nearest ones, for each of those points, you have to see which class it belongs. Let's say the nearest point, it belongs to class C1. Let's say next one also belongs to C1, next to C2, next to C3. So whichever becomes the majority class, that will be assigned as the class of the new data point. So this is called majority voting. So how do you find the posterior? In all the classification examples, we had seen that we need to find the posterior. That is probability of CK given data. Data, let's say, is X. So what is CK? CK is the kth class. So I'm saying what is the probability of this point belonging to kth class given the data X. This is what you call as posterior. And this posterior in k nearest neighbors can be calculated as kk by k. What are these kk and k? K is your k in KNN. In KNN, whatever you choose as k, that number is your k here. Why is it? Because in KNN, if I'm saying I want 5NN, that means for each of the classification, I'll be considering 5 nearest neighbors. So whatever may be the k that I'm choosing in KNN, that is the k that comes in the denominator. So if I'm using 5NN, then 5 is the denominator. And what is this kk? Kk is the number of points in that 5 that belongs to class k. Okay. So whatever be the, let's say I have C1, C2, C3 different classes. If I'm calculating P of C1 given X, then what will be the count? Let us say I'm using 7NN. Okay, 7 nearest neighbors classifier. And when I checked for one particular point, let us say there are 3 or let's say 2 points belongs to C1, and let us say 4 points belongs to C2 and 1 point belongs to C3. These are the 7 nearest neighbors of a new data point. Then my P of C1 given X would be kk by k. So that is k1 by k. So what is k1? The number of points inside the sphere or the among the k nearest neighbors that belongs to class C1. That will be 2 divided by what is my k in the denominator, that is 7, because I'm choosing 7NN classifier. Similarly, I can do P of C2 given X and P of C3 given X. Then I'll understand. I'm just rubbing this off. So then I'll find P of C2 given X and P of C3 given X. Then whichever gives the largest posterior, that will be chosen as the class. So this is quite logical and easy to understand. Let us see what are the positives and negatives of using a KNN classifier. If you are using a KNN classifier, the first positive is that there is no training phase required. You don't need a training phase at all. You simply have to store all the training data and your training phase is done. All the remaining work goes to the prediction phase. What is the next positive? Next positive is that this is a non-parametric method, and that makes it suitable for even any non-linear decision boundaries. Okay, so this is a non-parametric method. So this is the next positive. Why is it non-parametric? Because you don't use any parameters. What you're doing, you simply see all the distances to each point. So if required, you can say you have distance metric, and maybe you can consider weighting. That is a special case of KNN. That is, instead of simply seeing the distances to each of the points, you can use the weighted distance. That is another modification to the KNN. That is, if a point is very near to our point X, you can give a higher weightage to the class of that point, and let's say some other neighbor which is a bit distant from this point, you can provide a lesser weightage to the class of that point. So this is a modification to KNN. In general, what you do is you simply check the number of points that belongs to each class and then you assign to the majority class. That's what you normally do. Coming to the negatives of KNN, what are the negatives? First negative is that computationally it is expensive, right? Computationally it is expensive. Why is it expensive? Because in a prediction phase, you have to calculate distance to each point, find the k nearest ones, which is computationally expensive. Especially imagine if it is very large data. In that case, it will go very expensive. Next thing is it's not suitable for large data set. That's obvious from the previous point itself that you can't use it for large data sets, right? Large data sets. That is automatically obvious from the previous point that if you have large data set, it will go very expensive computationally. And the third point is bias. That is the bias that this model shows towards the data which is imbalanced. Let us say you have a data in which you have 1000 data points, out of which let us say 990 belongs to one class and only 10 belongs to another class. And let us say I'm using a 50 NN classifier. Okay, if I'm using a 50 NN classifier, wherever my point be, if you take 50 nearest neighbors, always the class 1, let's say this is class 1, the class 1 which has 990 data points in total will always win. What's the reason? Because there are only 10 points which belongs to class 2 in total. So wherever be a point, if you take 50 nearest neighbors, maximum representation from class 2 is 10 only. The remaining 40 will anyway be from C1. So any point will be classified as C1. So this is a bias that this model shows towards majority class if it is an imbalanced data set. This is the other negative. Otherwise, in case your data set is well balanced and you have a smaller data set, KNN is a good option.